This video is going to start exploring waveform relaxation methods. And this is the third class of time parallel methods that we're going to look at. So in this short video, what I want to do is kind of contrast what multiple shooting methods are with waveform relaxation methods. So first, let's step back a bit and recall the PDE that we're trying to solve. This is a very general setup. We're trying to solve a PDE in some spatial domain from x equals 0 to capital L. We care about the solution from some time 0 to some time capital T. And we're also given some initial conditions and some boundary conditions. All right. So the boundary condition is U is given at some time 0. And the boundary condition is for all time, I know something about either the solution U or its derivatives. Okay? And the way we normally like to visualize this is through this diagram. So on the x-axis, I'm plotting the spatial variable, and on the y-axis, I'm plotting time. So this is my computational domain that I care about. So x goes from 0 to capital L, and time goes from 0 to capital T. And in sequential time integration, what we do is, given some initial condition, which is this blue line here, we'll take a step to solve for the solution at some time t1, take another step to solve for the solution at time t2, and take many, many of these steps, and at the very end, we get the solution at time capital T. Okay, so that's a cartoon picture of what sequential time stepping looks like. Okay, so what we looked at before break was something called multiple shooting methods. And the one that has taken the world by storm are these parareal methods that Leonce and Madej introduced in 2003. So let me give you a quick cartoon of what that looks like. So here is my computational domain again. So I'm going from 0 to capital L and 0 to T in time. So this is space, and on the y-axis is time. Now, what multiple shooting does is it says, let me break my time domain into several large chunks. So in this case, let me break it into 3 chunks. Now, I have my initial condition at time t equals 0. What I do in parallel is I take a coarse propagator to get a shooting parameter at time t1, right? And the coarse propagator should be something that's really cheap and really fast. And then I use this coarse propagator to propagate the shooting parameter at t1 to some time t2. And now that I have my 3 shooting parameters, what I do is in parallel, I take a find solver to advance these shooting parameters at t0, t1, and t2. So in parallel, what we do is we advance this, and then we iterate. We say, well, so let me put this in words here. So we take the core solver. So this is something that's sequential to get initial shooting parameters. And then in parallel, we do our find solves, or a find propagator in each time block. And then what we do is we iterate, we update shooting parameters and iterate. Okay, and this really is the multiple shooting methods, or the cartoon behind the multiple shooting methods. Okay, waveform realization methods are completely different. So, waveform realization, so WR is going to be the acronym for waveform realization. So waveform realization is completely different. So let me give you a cartoon of what this looks like. So again, on my x-axis is my spatial domain, on my y-axis is time, and here is my computational block that I'm trying to find my solution on. What waveform realizations method do is they break the space-time block in space, multiple space-time blocks in space. Okay, and the question is, how do we solve this, right? So, well, we have an initial condition. So inside of this, let me call this omega 0, omega 1, omega 2. Inside omega 0, I have initial conditions. I have my boundary condition, which is prescribed at x equals 0. But I am missing a boundary condition on the right-hand side. If I knew what it was, then, I could solve and everything would be happy. But the idea behind waveform realization methods is you guess what this coupling or what this artificial boundary condition is for your interior to domain. So you guess or you specify we call them coupling conditions. So specify means guess. Coupling the conditions on interior domain. And then once you have these boundary conditions and the initial condition for each of these time blocks, now you can solve each of these subproblems in parallel. Solve PDE on subproblems in parallel. All right. And then what you realize is, oh, well, of course I made an initial guess for what my boundary conditions are. I don't really know what these coupling conditions are, but based on my solution on my two boundaries, on my two domains, I can update my coupling condition to be something more accurate. And you keep iterating until you get to convergence.